In this video, we'll explore two questions about the data set from North Carolina births. The first is we're going to explore, is there a difference in the average number of weeks a pregnancy lasts between pregnant women who smoke and pregnant women who don't smoke? And then the second is whether there's a difference in the average number of weeks a pregnancy lasts between women considered young and pregnant women considered mature. And we're going to talk about how can we use StatsCloud to answer these questions. And then by going through this video, you'll feel, I think, pretty comfortable answering the questions throughout the rest of the lab. So first off, we'll open StatsCloud and then download North Carolina births. Just like last time, we will then import that data. And then here's a link to a description of the data. And so this is a data set that consists of 1,000 different cases with information about births in the state of North Carolina. And you can read through all these different variables here. And please do that because you'll be asked about quite a few of them. All right, so we can see here we have a lot of information, and remember, one of these rows contains information for one birth. So we're answering the question here of, is there a difference in the average number of weeks a pregnancy lasts between mothers who smoke and mothers who don't smoke, right? So in other words, if you're a smoker, are you more likely to have a shorter pregnancy? That's a question that's certainly worth answering. So you can see over here the habit variable is the one that tells us whether the mother is a smoker or not. And then the weeks variable tells us how many weeks the pregnancy lasted before the birth. All right, and so the nice thing about when we're working with numerical data for two independent groups, right? So we have our smokers and non-smokers. Those are our independent groups. When we're working with that type of data, there's actually a hypothesis test built into StatsCloud. So it's a little bit easier than when we were working with strictly categorical data. So if I go over here to Analysis and click Run New Analysis, since we're looking at the difference between two groups, we go down to Compare Two Groups, and as we've learned, a t-test is appropriate in this situation. So we can click t-test. Now it asks for the grouping variable, right? So if I click on habit, our groups are the non-smokers and the smokers. And then we're, of course, looking at weeks, the number of weeks the pregnancy lasts, as the measured variable. And that's all I have to do. Then I run my analysis. And you can see a couple of box plots of this data. And then down here is where the analysis happens. Okay, so here's the results of the t-test. And so you can see here that there is a test statistic of negative 0.519, right? And so if we're imagining the t-distribution, that means that our test statistic is to the left of center. But we are doing a two-sided test here, right? Anytime we're seeing if there's a difference in the average between two groups, then we're filling in both tails of the distribution. And when we calculate what proportion of the curve is at our test statistic or further away, we get 0.604. Right? So remember what that means. That means that if we are operating under the assumption that there is no difference, then seeing some sample results like ours was fairly likely. There's about a 60% chance of seeing that, right? So when we have that large p-value, that's when we fail to reject that null hypothesis. And so, in other words, there is not enough evidence to suggest that there is a difference in the average number of weeks a pregnancy lasts between smokers and non-smokers. Now, before we move on from this question and take a look at another one, remember that we are supposed to be looking at whether the conditions, the appropriate conditions for running this type of hypothesis test are actually met. And remember, with looking at two independent groups and numerical data, we want to see data that is approximately normally distributed generally. So if I look at the smokers, that looks pretty symmetric. Let me zoom in on this just a bit. Let's see, is that gonna... There we go. Now we can see it better. So if I look at the smokers, that data actually looks pretty symmetric, which means it's probably fairly normally distributed. However, the non-smokers, not so much, right? The median's up here, and so there's a really long tail. So this data is skewed to the left. Now, there's two things that are worth noting here. One is, in order for the conditions to be met, it needs to be met with both groups individually. However, at the same time, even though I'm seeing this strong left skew right here, it's okay for us to proceed with the hypothesis test. Because remember that the one other factor is that if you have a really large sample size, right, a really large sample size, then even if the data is skewed, the conditions are still met. So if I go back here to the analysis and look, there were 872 non-smokers. So when that sample size is that high, even though there's that big left skew in the data, we're okay to proceed with our hypothesis test. All right. Now the other question we wanted to ask was, okay, so maybe smoking, being a smoker or non-smoker, doesn't affect the number of weeks the pregnancy lasts in a statistically significant way, but does whether the mother is a young mother or considered a mature mother, is that going to make a difference? And so if you go back and you look at the mature variable, we've got younger mom, and then if you scroll way down here until you start seeing mature, way down here, mature mom, what you'll notice is that it changes, it changes once you switch from 34 to 35, right? So mature mom is 35 and older, and then a younger mom is considered younger than 35. So if we break it down by this mature variable, is there a statistically significant difference? And so to run another analysis, it's really quite simple. I just go to run a new analysis. Same thing, t-test for independent samples. This time we're looking at the mature variable, younger mom versus mature mom. Still looking at the number of weeks the pregnancy lasts, and now let's run the analysis. So here I have a test statistic, a t-value of 1.211 and a p-value of 0.228. So if I'm using that 5% level of significance, then the p-value is still significantly larger than that. It's at 22.8%. So this would be another case where we would fail to reject our null hypothesis. And so we would say there is not enough evidence to suggest the average number of weeks the pregnancy lasts is different between younger moms and mature moms. Again, checking conditions. In both cases here, we do have a skew to the left. The reason I keep saying left, by the way, even though these are up and down, is because the lower numbers are down here and the higher numbers are here. So if you laid these horizontally, then of course the tail would be to the left as you go to the smaller numbers. But again, because the sample sizes are large, it's okay that we went ahead and proceeded with the hypothesis test. Finally, the one other thing I want to show you is because, sometimes box plots, they don't show as much detail. And so sometimes it's nice to look at a histogram when you want to judge whether data is approximately normal or has a skew to it. And so if I go and make one more chart here, I'll just show you. If you grab histogram and you want to, and of course we're looking at the number of weeks, right? If I create a chart right now, that's just going to give me one single histogram of all the data. But what I'd really like to do is look at my two groups individually. So what you can do is go to this split button. And this is something that when you do your final project is something that you very well may want to do as a graph that you display in that project. You're going to click Add New Variable. And so then you're going to pick whatever variable you want. Okay, so mature was the first one. That's the one we wanted. But I could also do it by habit, smoking and non-smoking. But let's click mature and click OK. And then create the chart. And then the nice thing here is it gives us two different histograms, one on top of the other, that we can look at. And like we just said, the box plots showed a left skew. Of course, the histograms are showing a left skew as well, a left tail here. But again, the sample sizes are large enough that we can proceed with our hypothesis testing anyway.